Welcome to Master Concepts in Chemistry. In this lesson, we'll learn how to calculate the number of moles and molecules in a sample of a molecule. A molecule is when you have two or more atoms bonded. Okay, so first of all, what do you need to know to be able to solve such problems? First, you have to know the relationship between mass, moles, and molecules. So I'll go ahead and write the following. So we'll say mass in grams is connected to 1 mole, and 1 mole is connected to molecules. So this means that if you want to go from mass in grams to molecules, you have to go through moles. So you have to first convert from mass in grams to moles, and from moles to molecules. So since we have to convert from mass in grams to moles, we'll need to use a conversion factor. So what conversion factor do we need to go from mass in grams to moles? We'll need the molar mass. So if we are moving in this direction, that is from left to right, that means that we'll need our molar mass, but our molar mass would have to be flipped such that 1 mole will be on top and then grams will be at the bottom, so that your grams will cancel out and you just have moles, which is what you want. Now, once you have moles, what else do you need to do to get to molecules? To go from moles to molecules, you need Avogadro's number. So you have to recall that 1 mole of any substance contains Avogadro's number. So I'll write 6.02 times 10 to the power 23 molecules for 1 mole. Okay, so once we have our moles, we just multiply our moles by Avogadro's number of molecules per mole. So the moles cancel out and we just have our molecules. Okay. So this is the direction you need to recall. You have to go from mass to moles to molecules. So from left to right. Okay. So that is all we need for this particular problem. So let's look at an example. So this is the question. So the question says, how many moles and molecules are in 2.00 grams of glucose? So you've seen that the question is asking you to figure out two things, moles and molecules. So first, since to get molecules you have to go through moles, that means once you are going to molecules, you definitely have your moles. Okay, so yeah, so that is the problem. Okay, so what else do you need? Now the chemical is mentioned, which is glucose, but the chemical formula is not given, so that means that you have to know the chemical formula for glucose, and the chemical formula is C6H12O6. And recall, in the first step, to go from mass in grams to moles, we need a molar mass. So if you go back, we have our mass in grams, so we have to go from 2.00 grams to moles. And to do that, we'll need our molar mass. Okay, so we have to find the molar mass of glucose. So to find the molar mass of glucose, you calculate as follows. So we have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. So we'll find the molar mass of the 6 atoms, the 12, and the 6 oxygen atoms, and add everything together. So this is how you set it up. So we'll say 6 times the molar mass of carbon on the periodic table. So you look on your periodic table, so you see that carbon has a molar mass of 12.01 grams per mole. So we go back and then we say 6 times 12.01 grams per mole. Then we close this, put in parentheses. Then we'll add it to, we'll move to hydrogen next. Hydrogen, we have 12 atoms of that. So we say 12 times the molar mass of hydrogen. So we'll go back to the periodic table. So you see hydrogen has a molar mass of 1.01. So we read the bottom value below our hydrogen, which is the atomic mass, but we want molar mass. So we just add grams per mole to it. So that is 1.01. So we go back and we say 12 times 1.01 grams per mole. Then we move on to the next plus. So we have 6 oxygen atoms. But the molar mass of oxygen is 16. So if we go and look for oxygen, oxygen is in group 16. So you see that 16 here, so it has 16.00. Okay, so the molar mass is 16.00 grams per mole. So we go back, so we multiply our 6 times 16.00 grams per mole. So once you add and solve, once you add everything, your answer should come out to 180.18 grams per mole. So this value is the molar mass of glucose. So molar mass glucose. And remember, you see C6H12O6. So that's the molar mass. So now that we know our molar mass, we can now convert our mass in grams to moles. So to do that, we set up our table. So remember, I always say set up your table. And then the value that is given to you, which of course is grams, we write it here, the top left corner. So we say 2.00 grams of glucose. So if you want, you put 6H12O6 just to say that is what I'm calculating for. So from our diagram, we have to go from mass in grams to moles. And we need our molar mass. So that means that we write our molar mass over here. But remember, we want moles. So moles on top and grams at the bottom. So it's glucose, C6H12O6, C6H12O6. So in our molar mass of glucose, we have 180.18 grams per mole. So the 180.18 goes with grams, and then the 1 goes with moles. So 1 on top by moles, and then 180.18 grams. So we close the table. So as you've seen, units on the diagonal will cancel. So grams, grams. So if we set it up such that the units on the diagonal don't cancel, then that means that your table, the setup is wrong in your table. So you can easily cross-check and figure out where the problem is. Okay. So now we have our moles because the grams cancels out grams. So we have our moles. So this is the setup for our moles. So what we need to do is the grams cancels out. So we just have moles. So we multiply the 2 by 1 and divide it by 180.18. So once we do that, our answer is going to be 0.0111 moles. Okay. So remember, we don't want to end here. We want to still continue all the way to molecules. But this is our answer for our moles. Okay. So if you want to put this to trace, and since the trace significant is the least here, yeah, normally one has infinite number of significant figures. So yeah, so 3 is the least. So you can rewrite this as 0.0111 moles, just like we have. So to trace significant figures, because these leading zeros are just placeholders, they are not significant. Okay, so yeah, that is if you want to include or think about significant figures. So this is our moles. So this is where we end for moles. But remember, we don't want, our question also says to calculate molecules. So that means that once we have our moles, we can continue all the way to molecules, which is the same as saying extend the table to include molecules. So what I'll do is I'll erase this. Okay, since we know what our moles should be, I'll erase this and then I would extend the table. Okay. So the next unit we want is molecules. So molecules here of glucose, C6H12O6. Okay, and then of course here will be 1 mole of glucose, C6H12O6. So as you can see, mole. So the units in the diagonal will cancel. So if we go back to our diagram, you notice that to go from moles, which is here, to molecules. So we are here now, moles. So we want to go from moles to molecules. So what do we need? We need to use our Avogadro's number. So the Avogadro's number, which is 6.02 times 10 to the power 23, goes with molecules, and then 1 goes with moles. So that means that if we go back to our table, 6.02 will be written here. And then the 1 mole is already here. I already wrote it earlier. Then we'll close our table. So units on the diagonal will cancel. Okay. So once you solve this, you should get basically 6.68 times 10 to the power 21 molecules of glucose, C6H12O6. Okay, so that is our molecules, okay, of glucose. Okay, so as you've seen, to solve such a problem, you have to recall this relationship. You have to recall the mass is connected to mole and mole is connected to molecules. And to go from mass in grams to moles, you have to use your molar mass, but you have to flip the molar mass such that moles on top and grams at the bottom. And then the grams will cancel out and you just have moles. And once you get your moles, you want to continue to molecules because the question also says calculate molecules. So to go from moles to molecules, you need Avogadro's number of molecules per mole. So here you don't have to flip anything, you just set it up like it is. 6.02 times 10 to the power 23 molecules per mole. So the moles cancels, the moles will cancel out and you just have your molecules left. So eventually, yeah, you just multiply and divide. And your answer would be 6.68 times 10 to the power 21 molecules. Okay.